My name is Nick Angel, and I'm Director of Engineering for ATS Cambridge Life Sciences. Together with Frank Schmidt, today we want to talk to you about the journey to automation for a product. Specifically, I want to discuss the design for automation process and its importance within the product development cycle. Let's look at the following typical scenario. Company X has embarked on the development of a small but complex product which will be used to automate injections of an undisclosed vaccine. Company X knows they have a hit on their hands and expect worldwide sales in the tens of millions of units per year. Company X also has the ambitious target of bringing the product to market in less than 2 years and begin shipping at full capacity right at the gate. These things are important to Company X because they want to maintain an advantage above their competitors, and they want to make sure they protect their IP. Looking closer at this scenario, we find that Company X has quite a few challenges on their hands. First, automating a small yet complex product is not easy. Two, they definitely need automation as worldwide sales in those volumes won't be achievable with manual assembly unless you have a very large scale operation. Lastly, bringing the product development and the automation development cycles to a close within 2 years is a very stringent timeline. This is achievable, however, Company X needs to do quite a few things right to hit these milestones. If we look at a typical product development cycle, we find the following phases: concept development, prototype design, final design, and post-market launch, a sustainment phase. If automation is needed right at the gate, the automation design cycle should start around the time when the prototype design begins. Within the prototype design phase, there are several prototype builds. Depending on the complexity of the product, the number of builds varies. However, between each set of builds, the design team will analyze what went well and what improvement opportunities there are, and they will make these changes to the design of the product for both functionality and aesthetics. These are perfect times to complete the DFA analysis, or design for automation. Of course, the automation design will continue in parallel with the proto builds. In the final design phase, we have several more product builds called the MPI, or new product introduction builds, and a final build called the mass production build, which gets the product ready for market. These are usually sellable units that will be used at market launch. Between these MPI and mass production builds, there are more opportunities for the design team to make changes to the product. However, the product is mostly locked in by this time, so changes and improvements are on the smaller scale. DFA can continue to be done at these phases as well in order to continue to evolve the automation design. So what is DFA? The DFA process is the design for automation that prepares the product for automated assembly. It challenges product designers and automation engineers to work together to examine how the product design accommodates automated processes with little or no human intervention. There are key design elements to be considered as part of the DFA process: the assembly sequence, the fastening methods of the product, the part tolerances and the stack up of tolerances when these parts are put together, datum features, temporary product features that are only used during the assembly process, and process cycle time. All of these elements are key to successfully building automation that can put the product together repeatedly with very high quality. There are several typical ways to use the engineering resources for design for automation process. Large companies will have in-house automation engineering teams that work with the product design team to develop the automation in parallel with the product development. This is the ideal scenario for Company X. However, most companies are not large enough and do not have their own automation engineering teams in-house. The more likely scenario is where the product design team completes the DFA analysis as part of the product design, but then will focus on the automation design post-product development. This will not work well for Company X, as doing the product design and the automation design in sequence will not meet their 2-year stringent timeline. The other scenarios where the product design teams work with an external automation company to develop the automation in parallel with the product design, but each team focuses on their strengths, being the product design or the automation design, depending on which one of the companies we're referring to. There are definitely challenges with completing the design for automation um, process properly. One is diverting the right amount of engineering resources and setting their priority of product versus automation. More often than not, the product will take the priority and the automation design will fall behind in schedule. Next is the varying product demand forecast that will sometimes put the automation design on hold or change the direction of the type of automation required based on changes in the forecast seen in the market during the duration of the product development cycle. Lastly, some of the product design features and or processes simply can't be automated, thus requiring the automation engineers to come up with creative ways of potentially semi-automating or having offline processes that are embedded with the automation lines. If completed correctly, there are quite a few benefits of the DFA process. The automation lead time is reduced. The automation costs are reduced because multi-op stations, buffers, or complex stations may no longer be required. Automation planning can be done more accurately and line up better with the product demand needs. And if not needed right at the gate, minimal product changes will be required later if automation is introduced in the assembly cycle. So how can ATS help you with DFA? ATS design team has completed DFA for hundreds of products across many industries, regions, and customers as part of the automation design. ATS has the engineering capacity to be involved right from the start and work at the pace of the product development team, providing regular feedback and coaching. ATS has a pre-automation team that can help bridge the gap from manual assembly to automation as existing products. I hope you found this presentation informative, as design for automation is one of the most discussed topics within the ATS engineering team.
In the first part of the presentation, you heard about product and automation. In the second part of the presentation, I'm going to talk about optimize your process before you automize it. In particular, we are going to have a look at what makes a process good for automation, what are the principles. We will have a closer look to one good example that might be automized in the next step. We will ask ourselves what needs to be done before automizing and what needs to be considered. And then we will have a look at a real-life example and how to approach it. Here are my 6 principles that I think are important before automizing a process. Number 1. If you automize a waste process or a process that considers waste, it still will be waste. Number 2. You need to decide what kind and what amount of historical data you will need in future to track and trace back in case if. And it's more easy to implement if you consider it from the beginning than later on. Number 3. Standard work is key for automation. Standard is important. Number 4, think about having the right material in the right place at the right time. Sounds easy, but logistics is the key, always, from my point of view. And information drives logistics. Number 5, you need to understand if there is any variation in your process brought in by material or the process itself. You need to consider that humans can easily deal with variations, machines cannot. Number 6, you need to define your strategy, how to ensure the quality. Quality is always first. And there need to be clear rules that even machines can judge if a part is okay or not. Sounds everything reasonable and familiar to you? You think it's no rocket science? Well, let's have a look to a well-known high-performance process and what you would think how to automize it and what to consider. Formula 1 pit stop. There are 4 tires changed within 2 or 3 seconds. Let's have a look how this is done. So all the material and all the tools are available when they are needed and where they are needed. There is a clear flow and a clear process for everybody to be followed. There is no waste, almost no waste. Everything is focused and everybody is focused on a maximum performance and speed. This process is, from my point of view, benchmark for repeatability and standard work. The what, the how, and the when is clearly defined. On the right side, we have the topics. There is a clear start and a clear end for the process. So the guy with the flag, he indicates when the driver needs to brake and when he can go. He's collecting all the feedback. It's a documentation light that he's collecting all the feedback, because everybody is raising its hand when he's ready, and then he lets the car go. Quality matters, of course. Imagine a tire would be loosened and would be lost during the ride. So there is everything indicated and provided that this must not happen. You think this world-class process can be easily automized and is ready for automation? Well, then let's have a look. Even this process needs, from my point of view, further investigation and some planning before automation. So the guy who is lifting the car, he can adjust to the position where the car comes to a stand. If this is varying by a few inches, he can adjust to it. So how would we automize this one? The guy who is untaking the tire, he can do it wherever the car is positioned in the end. And he can provide some rocking motion to the tire if it will stick on the axle. How would you automize this one, this kind of variation? The guy who is screwing the tire, he's doing a kind of visible inspection and makes sure that the nut is fixed. Think about how to automize this one. And the guy who is collecting all the information and keeping the overview for the entire process, he's only giving a release when everything is well done. How would you automize this one? So what does it mean? It means you should really check each and every process step before you think to automize it. And furthermore, you should think about what is your goal? What are you aiming for? So in our example, it would be a once in a while automation, I called it. What do we need to do? So we would solve the issues from the previous page, think about if there would be more issues that need to be solved. We would find some smart solutions to automize it. And then the only thing is really to think about if it's reasonable with payback and amortization period. If you would consider automizing such scenario in a mass production, you would do it maybe fully different. You would challenge the entire process, the entire flow, the entire supply chain. You would gain a vision of what would be the best material flow for mass production and the related supply chain. You would think about what would be an information flow to have everything at the right time, at the right place. You need to think about the quality topics and the boundaries in the process. And of course, also in such setup, you would need to think about how to solve the issues from the previous page, all the nitty-gritty details. I think it's really, really important to create a common vision of a target status, and this will help to do the right things and to do the things right. Let's have a look to a practical example. We are in the field now of automation. It's automation of a material handling process. It's in a warehouse of a production site. So it means many forklifts going around, racks and shelves involved and all stuff like that. The customer would like to automate this process, and he has clear targets on what he would like to reach with it. Target number one, he would like to reach a 25% headcount reduction with that. Very ambitious. Target number two, he would like to get rid of safety issues and safety incidents that he had lately in the warehouse there. And number three, it's a local project and it's in a global setup, and it should be a blueprint for a global rollout. How would we approach this one? We would start with analyzing the current material flow. So to understand where is the material coming from and where is it going to. We would use the tool of a Sankey diagram, which would clearly indicate and show an overview of the entire flows. Once having done this, we would add the related information flow. Logistics is nothing with the right information in place. So we would do this one with a value stream analysis to see how the information flow is performed currently. This will give you a structure And this will also provide ground for improvement. And the beauty of a value stream analysis is that you can add additional layers to this. In our case, this would be a safety layer. Having done this, we would perform a potential analysis, which means we would cluster current issues and topics and think about potential improvements that are shown with the outcome of the analysis. All this is a really important base for the next steps. So having done all the first 3 steps, we would understand where is the material coming from and going to, what is the related information flow. We would have added the safety topic, and we would have had a first potential analysis, what and how to improve. With all this, you could create a vision. What is the goal? Where would you like to go to with the process? Which principles should be included ideally in terms of safety, quality, layout, and so on. With this, we get everybody to the same starting line and in this project. To create a vision, we would use then the value stream design tool, which means we would think about what would it mean implementing this process in a greenfield environment, in a greenfield approach. And then in a second step, having done this, we would think about how turning this into a real life scenario. So how could it become real? And this then, all of this would be then the input for creating specifications for hardware and IT systems. And this would be the input to adjust the layout and the process descriptions accordingly. If we build a bridge to the example with the Formula One car, we can see that we consider with the Senki, we consider all the variations in the process. We try to find out how the logistics is currently doing and will in future do. We consider the information flow. We think about standard work with creating our vision. What is the best possible process that can be done? And then we turn it into a real life scenario. Coming to the takeaway box on the right-hand side, from my point of view, before automizing a process, you should really define your vision. You need to select the right tools to go along. In our case, it's a Senki. In our case, it's a value stream analysis and a value stream design. And then it's always the same, optimize before you automize. Thank you very much.